So we have discussed about the landscape yesterday, right? So, so when we have discussed about the landscape, so we have discussed few things, right? Which is, let me go to my GitHub repository. So we have discussed about the strategic. We have discussed about the segment level. We have discussed about the capability level, right? So those things we have discussed. Right. So far we have discussed about the BDAT. We have discussed about the states. We have discussed about the scoping architecture. We have discussed about the architecture levels, which basically I was talking about, that it is strategic level, segment level, and the capability level, right? So far, actually, what we are doing, we are learning the terminologies, right? We are just before starting the ADM life cycle, I want that we need to have certain base into our mind, which basically helps us to which basically helps us to understand that ADM more clearly. Okay, so that is the objective. So right. So now, so we were talking about the architecture level. Then we have discussed about the architecture partitioning. In the architecture partitioning, I have mentioned that you will divide your, you know, overall architecture roadmap into different subsets. And those subsets are basically helpful for developing, governing, and managing your complex architecture more efficiently. So partitioning, whenever you are creating, you are basically concentrating that who is the owner of that particular partition. Like if it is related to a particular uh, team or group, who will be the owner? For example, if it is a database related, who will be the database governing body? Who will take the ownership, right? So ownership is required. Then rest of the things comes, right? So we have discussed all these things with respect to our food delivery app also. So,
Rahul, are you sharing something?
oh, sorry, I'm not hearing. Oh, sorry. All right. You can see now the screen.
Yes.
Right.
Yes.
So now let me ask some question. We have discussed about the partitioning, right? So what are the benefits of partitioning, do you think? Any benefits which you think that, yeah, this will be very helpful.
So I believe,
And it,
for the partitioning, like, you are actually breaking down the big chunk into small or, different boundaries.
Mhm,
Uh, and, and at the same time, you will have, each boundary with a separate governance and ownership so that, you
mhm,
can actually, manage it better rather
right.
than, rather than you do it, a big chunk, that will be a little bit more complex to manage
Mhm.
it, from my understanding. Okay.
That's correct. That's correct. Very good. Any other point which comes into your mind?
Well, I also believe that, this also can help, for better governance. Okay.
Governance, execution, right?
Yeah.
Responsibility or the ownership, right? So everything requirement, right? You can break down the requirement. For example, you are saying that this is related to AWS solution architect, right? So now the requirement is specific to AWS solution architect, right? So that is also benefit. So let us see some bullet points related to this partitioning, architecture partitioning. So architecture partitioning is a practice breaking overall enterprise architecture into smaller, manageable, modular component called partitions, and that can be developed, governed, maintained independently, but still aligned to the enterprise-wide standards. Why partitions? Large enterprise is complex, right? So trying to design and govern one single monolithic architecture is insufficient. Because if you put everything into a single architecture, so this is insufficient, slow and error prone. So partitioning brings clarity, ownership, speed, and reuse, right? Now um, consider this reusability. Consider you have developed one solution. So there are two cloud-based companies, two cloud-based architecture you are using. One is AWS, one is, say an example, Azure, right? Or maybe GCP, or maybe something else, right? Now, maybe you have done a partitioning that we will have a solution architect who is working on this. So he has designed one network diagram, right? How the network flow will work. So now he has designed this network flow diagram. You want to reutilize this network flow diagram into GCP or Azure also. So in that case, these three cloud-based platforms are different, but concept-wise, they are same. Concept-wise means, for example, they want to provide the solution that your infrastructure is on the cloud. So their networking concept, their security concepts, it's almost similar. Okay. So can we reutilize this? Yes, this we can reutilize if we are having, instead of monolithic approach, we are going with the partitioning approach. So problem, enterprise architecture is too complex. It's very difficult to understand. See, you as an enterprise architect, when you are getting the requirement from the client and you design the enterprise architecture, so at that time, if you are only working on that, or your team is only working on that, then without collaboration, without communication, it's not possible. As an example, there is a part where you need to apply the change management process, how the change management will occur, right? So for that, you need to talk to the ideal people. So TOGAF is not only the standard which it strictly follows. It have a space where you can integrate um, other terminologies, other technology, other tools into this. For example, if you think that I need to apply a agile process into my TOGAF standard, yes, you can incorporate into this. If you say I want to have the something which is related to my, like Dynatrace, I want to add. I want to add ServiceNow. I want to add some other management tools, right? So yes, you can do that. So ultimately, your complex architecture, you need to divide it into small parts. So you are talking to the development team and or maybe infra team, and you are saying, hey, you need to manage the infrastructure. So they are saying that, okay, how we will manage? We want we want a Dynatrace team. We want to apply a Dynatrace agent on our servers, which will monitor through the Dynatrace application, and it will create the ServiceNow tickets. if there is a if there is something an issue occurred. Okay, so it means so this knowledge as an enterprise you only get when you talk to these teams. You will check with the ServiceNow team. They create the ServiceNow tickets. So there are some standard tools which you know, which you should always know. For example, if you are working for a company and you are the enterprise architect over there, your first questions which is related to the process oriented, right? You need to know the processes. I'm not talking about the business process. I'm talking about how what are the things which that IT company is basically offering. So say an example, they are saying we can help you to create the or onboard the customers on the service now. We can provide Dynatrace. See, I'll tell you one real-time scenario. I was working as a solution architect for cloud-based and the DevOps side. I was very much comfortable with Kubernetes, containerization, and cloud-based system. Right? Now there is a new requirement came from a business point of view. The requirement was that they are using a Kubernetes cluster. Okay, they are using a Kubernetes cluster where they already have that environment set up on their on-premises environment, right? And they are creating all their Docker images. Docker images are nothing but the images where the application's code is in the form of executables. They are having their own cluster. Now they come to our company and they were saying, hey, what we need to do? We need to monitor our applications. That is their first requirement. Second requirement, they are saying there should be a dedicated team who can work 24/7 and report to our or they can provide some solution. First of all, they can 24/7 if some issues occurs, so they are capable to provide solution. Okay, what solution? For example, there is one application which is running as a container, right? And that application is down. So it should be monitored that you should know that some application is down, whether automatic replication is applied. If not applied, then what will be the possible solution, right? So they are expecting that we need to create a design in such a way that because they are facing the issue if some containers are down. So I'm not going in very technical way, but just wanted to share this kind of scenario, which as an enterprise architect we received. So that was a big project actually, even though they have set up everything on their Kubernetes environment, but they are facing a lot of issues. Their ports means containers are down. They are not able to monitor the servers. They want their applications, there are some applications, right, which is called ingress applications, right? They want that this is to be managed by some controller. There was a lot of network issues. Maybe some ports are not opened. Maybe something which is outbound traffic is not properly configured. So they come to our company and they are saying that we are also IT based company, but we want to outsource this. how much time it will take, what will be, uh, who will be taking care of this. Give me a very high level plan for this. Now, let me ask that questions to you. You understand the problem? There is a Kubernetes environment, which is already they are using on-premises environment. They want to monitor their applications. And there are so many technical things are there. Okay. Enterprise architect may not understand that. They want to monitor their application. They need the solution, immediate solution. They need that, their department, they come to know that there is an issue. They need to know that if there is a configuration issue from maybe when they have designed some Kubernetes cluster. So at that time, there is some design issue, means some ports are not open, network restriction, etc., etc. So they want to know everything. So now you are as an enterprise architect, this task is given to you. Now tell me one thing, very high level, not in very detailed level. First thing, do you know what, as the IT company where you are working as an enterprise architect, what they are offering? Do you think you need to know those offerings, Raghu?
Can you repeat
Ye-
that? What is it offering you?
So my question is that, for example, you are working for an IT company as an enterprise architect,
Mhm.
and that company is providing some offering, like they are providing service now, tickets using ServiceNow. They are providing monitoring using Dynatrace. They are having some in-house applications, okay, which are very standard, or these are commonly used by that company where enterprise architect is working. So do you know that he should be aware of all these before going to this providing the solution to the customer?
Yes, definitely it helps
Right.
because there will be some um, kind of a skill set available with the company, and they know the pros and cons of it, and they can easily identify whether this solution helps the company to overcome their problem, or they need to identify something new. So those kind of uh, things can be analyzed easily if we know this thing.
Good. Good. Now, John, my question to you. For example, 80% of the work which client is demanding, your company is offering. Consider Dynatrace, they are not offering. Now they are saying we need the 20% of the work which is related to, say, an example, Dynatrace, or maybe something else which your company is not offering. But 80% of the work, you know that we can do that. Means if we get this deal, then 20% part is there, but our company is not doing. Will you reject this project, or what will be your approach?
Yeah. So so my approach would be like, I will look for the capability to cover the remaining capabilities. Okay. So for example, in this case, we are saying that, we don't have the monitoring capability.
Hmm.
So Dynatrace or, any other tools. So probably I will look for that solution also integrate into the offerings.
No, but your company does not have that one.
Okay.
So this 20% work, not at all. There is a 0% chance that your company can deliver this. But 80% you can do. And consider this is a big project. And you want to give the confidence and not the fake confidence, actual confidence, real time confidence to your customer. Yes, this 20% also we can do. We are not offering, but we can do. But your company, you don't have such kind of capability. What? So my question is that, first of all, will you accept the deal or will you reject the deal? Means you say, okay, we cannot do this 20%, so reject this entire deal.
So as I understand from you, from a company perspective, we can't do the 20%, right? So that
Mhm.
means, we don't have the capability or we can't
Right.
do it, right?
Yes.
Um, so in this case, I'm little hesitant, to give a to accept the offer because see, it looks like this is also one of the key requirement from the client side,
Hmm.
right? And as an enterprise architect, I don't want to give false promise.
Hmm.
Uh, so I don't know. I don't want to say I'm going to reject it. That is also something bad on the enterprise architect.
Okay.
But
So if you accept it, how do you handle this 20% of the work? What will be your approach? If you reject, then project is gone. Your company does not want that this big deal is to go away because majority of the work we can do, right? And client is also having, because 80% you are giving the guarantee and you have the, existing customers. So client is also having some, trust on you. Consider you are a big brand company. So now because of 20%, first of all, means you said correctly, we need to accept this offer, right? Now the Raghu, my question to you, how you will handle if you accept this, how you will handle this 20% work? What will be your approach?
This we can consider it as a risk at the initial phase.
Okay,
But we can handle it either by outsourcing this particular subtask is one option.
very good,
Other
very
one
good.
is we can take some breathing time from the client for this particular 20% activity and get the resources onboarding with the right skills.
That's great. That's great. See, basically what we are having, because majority of the work we are offering to the client and we are having, we are known for that kind of work. So that's why client came to you and they are saying, okay, 20%, how do you will handle? So you are having two options. First option that you will hire the people, you will make a team, your company does not offer it, and you say, hey, we need Dynatrace team. So your IT company say, hey, what is Dynatrace? We don't know. So then you can say, this is the requirement which we are getting, and this is almost 20% of that. So company says, no, no, we cannot do that. If they can hire the people, which is for Dynatrace, then it's well and good. If not, then outsource. You search for a company who is providing the Dynatrace. You have heard so many times that, for example, you are working for an IT company and they outsource their work to the another IT company, right? So I was working on a company, some big company in Bangalore, and they outsource their some of the projects. Not they have not outsourced. Microsoft has outsourced to our company. Then I was thinking, what Microsoft cannot do? Microsoft is, they are giant. They have everything, but they outsource to our company, and that I understood when this project came to us, right? So I am not exactly remembering. It's little bit old project. there was something which we were not able to do that 20% of the work. Then we outsourced it. So we are the IT company. We can provide the IT solution. We are providing the solutions to Microsoft, to Dell. Then why not we can develop this, or we can build a team for that solution? Because my company has certain restriction. My company does not have the team. If they hire, uh, they don't have that capability. So there are different IT companies, they are providing that solution. We will outsource that project to them. So in that case, now we will tell to the client, this 20% work will be done by some other IT company, but it is under our control. Is it clear to both of you? Any question?
Yeah, got it.
Right. So,
Clear.
yeah, good. So now there is sometimes happens, not sometimes, most of the time happens that you are working on a monolithic architecture. Monolithic means in one architecture, you are putting everything. So if you put everything, for example, I'm developing a solution, right? And that solution is, I'm deciding, okay, this will be done by, means I'm not providing proper ownership, team one, this will be provided by team two. But I'm not clearly mentioning, because I'm embedding everything into one monolithic architecture. I'm not dividing teams properly. I'm saying, okay, monitoring work will be done by enterprise architect, but he will send it to someone. So I'm not doing the partitioning. So in that case, there is a chance of conflict. Once I had given you one example that there was a file which we received from the one source, and our application is putting it into some client environment. So now there are three partitions: one partition, second partition, third partition. If any problem occurs, we can talk to the respective team. But if this is a joint, no partitioning, I'll say file will come, file will handled by the application, and it will send to the client. But I have not decided or created any boundaries. Then it is difficult to blame, or it is difficult to find out. Means you can find out, but it will be very hard if something happens. So team says that it's a file, who is shipping the files, it is their problem. They are saying, no, it's application problem. So there will be always a blame game starts. But if you are having the partitions, then it will be easy to understand the flow, easy to find the issue, and we can manage these conflicts. So now, um, right. So for example, the operation team may use the certain database for delivery tracking, while the customer experience team wants to use different stacks. Partitioning make the boundary clear, helps the reconciling the conflict via architecture governance. Parallelism. See, when you divide a project into different subsets, so you are having your enterprise architecture roadmap, right? So you are having that roadmap. Now you are saying, okay, we are having technology, or we are having, we are having data, we are having technology, or we need to create the apps. So they can work together or in parallel. For example, they are defining a table, order table, and they need a corresponding a web form. So through this web form, we are inserting, updating, deleting the data into this order table. So in that scenario, the application team will start working. If they are having a, you know, design only what how the order table will look like, or maybe they have created order and now they are working on other part. So you have started working on the order table, right? So now the application team and the data team, they can work together. Maybe some other teams also they can work together. So it will be speed up your work, right? While customer team is designing the loyalty app, the logistic team is building the courier tracking app, all under their own partitions. Reusability. Now this order table is used for web application, for reporting, for desktop based application. So now you can refer to this order table. Maybe some other API is also using this order table. So you need not to create separate order tables or separate, entities for reporting desktop or web. Maybe you have created a library into your code, and that library is you are using for application one. Maybe like you want to create the logs. So you are saying, okay, when I'm writing the desktop application, when I'm using web application, when I'm using the API, so I will use the logs. And you have created one module for logs, and you can use in all these applications. So that is the reusability of the architecture artifacts. Right? Problem without modular architecture, it's hard to reuse the good design. Solution: partitioning creates the modular self-contained architecture segments that can be used across the different initiatives. Easier to maintain the reference architecture and the solution platform. So now maybe you are understanding the uh, purpose of partitioning, how useful it is, right? So now, say an example, this is the partitioning model diagram. So enterprise architecture, strategic architecture where you have common vision, principle, goals. Now what you are doing, you are creating a partition for customer architecture where you are creating the customer apps, order management API, partitioning for operation, delivery flow and courier app, and partitioning for finance, another team, which will taking care of the payment system, invoicing, tools. Okay. So this is about the architecture partitioning benefits. So yesterday when we were talking about, right, so we were talking about that abstraction level. See, whenever you are going to the customer end, right? I was asking one question to you, that what will be your first step, how you will approach to the customer to know about the business. So in that case, what you will do, you will talk to the very high level that tell me what are the different people or units and who are the stakeholders, right? So basically, when a project comes to you and you need to contact to the very high level of business management, so you need to drill down to the smaller problem areas. You need to ask some structured questions which are related to your architecture, because ultimately you need to design a particular end-to-end flow for your enterprise architecture. Okay. So as I was saying, for example, you are going to some business unit and they are having some problem that whenever we need to scan the document, we just take the hard copy, we scan it, then we upload it to our system, and then we are basically uh, then it gets stored into some system. But if that system is down, we cannot perform that operation. You must have experience something like that. You are calling to the mobile customer care and they are saying our server is down because they are not using cloud-based system. So they are saying our system is down. Can you call us after half an hour? So this is one problem, right? So that person is telling, or that business person is telling this problem to you. So that is an input for you to design the enterprise architecture. You need to know few things, why they need it, right? How they are doing their existing work, right? What they are doing, right? And the next one is that with the what, right? With what means like what are the resources they are using. So why is called the contextual writing little slow. Second. So this is contextual. Now you need to ask some questions. You need to go to that problem area and you need to divide that problem area into smaller problem areas to design your model and the solution. But first thing you are asking why it is required. Why the new architecture they are looking for? What is the problem in the baseline architecture? So that is first thing which is called the contextual, which indicates why. Second is how, which is logical. Logical means how do we structure the functionality? Okay? How we structure the functionality. So now you understand why they need it. What are their main problems, right? Maybe you will ask about what also, which is the conceptual model. So here you are asking what functionality and other requirements are needed to what they are looking for. Okay. So, so you need to know why, you need to know how, you need to know what, and you need to know that with what. With what is the assets, right, we shall implement for this structure. So these are called the abstraction level. So you need to go deep and deep. You need to understand a higher level to very small level, right? So now let us understand these things one by one. First is the contextual abstraction. In contextual, we need to understand, in contextual, we need to understand the environment of an enterprise and the context of the architecture work. In context, what do you have? Scope. What are the different drivers? You need to know the goals. You need to know the objectives. So contextual abstraction, understand the environment of the enterprise and the context of the architecture work. Second is the uh, conceptual, which is nothing but what. So you need to understand their requirement. What are their problems? So this is conceptual. So you need to understand the problem. Requirements, but they are looking for the solution. Their service model. Can you give some examples related to this? Conceptual, John, where you need to understand the problem, requirement, service models. Let's take one example of a banking department or banking project.
Yeah. So this is, just to identify what are the end-to-end requirements.
Mm-hmm.
See, for example, like, so if it is actually for a banking, so
Mm-hmm.
need to understand whether, this function is actually going to support the, the end customers, or, or this is actually for the partners.
Mm-hmm.
So that can be one. And what are the key requirements, to support that?
Yes.
Then then other things can be like, which are the business functions, who are actually
Very good.
going to use it,
Very good.
right?
Yes.
And again, what are the services are we planning to integrate, with this, what do you call it, with this,
Excellent.
with these capabilities, right?
Excellent. Excellent. So it will be the business services, maybe application services, and the technology services. So these are the example of the conceptual of the when you are understanding the problem. Very good. Now, next is the logical. How? So in logical, we need to identify the something which say uh, implementation independent components. Okay. To to achieve whatever is in the conceptual model. For example, you are saying that we have the conceptual model, which is business services. So we need the business data. Right? We need application. Then for application services, what applications are required? So someone is saying business service, but how the business service will be implemented? That comes in how? Technology. With technology components we are using, like servers, infra, networking, etc. So technology. So this is how. So you need to divide your architecture efforts on these abstractions level. Now, fourth one is with asset. So that is basically physical abstraction. So physical abstraction is that you need to find an alternatives for the allocation and the implementation of the physical components, which will meet your logical these components. So Raghu, what do you think? What comes here in the physical? Any example? Physical abstraction. So its main objective is that whatever the logical uh, in the logical abstraction, which is basically the implementation of the conceptual problems, how we can plan for the implementation.
Here we need the tools and technologies,
Tools and technology, very
right?
good. Yes. So yes, you are correct. So what are the tools we are using to implement? Which servers we are using? What technology we are using? Correct. Now we have discussed about business. We have discussed about data. We have discussed about application. We have discussed about the technology. Now, question to both of you: tell me these abstraction levels, whether do you feel that these are related to these domains?
Yes.
Yes, exactly. Because here we are talking about these abstraction level, right? And these abstraction levels are related to business because we are getting the requirement. We are talking about the data where the, you know, logical conceptual model comes into the picture. Application where the implementation comes into the picture, and technology where we are developing the application as well as we are implementing the application. Now, let us talk about one more thing. So, any question related to this abstraction level? Now, let me. We have discussed about the landscape. So, this is the breadth. These are the these are the levels. Right, architecture level. We have discussed this one, and I have mentioned this is time. So, there is enterprise strategy. Then we are having segment, and we are having the capability. Right. So we have discussed why on textual, what, which is conceptual, how logical, and what is assets or physical abstraction. Now, uh, when we talk about these abstraction level, so they describe the level of abstraction in our landscape. Right? For example, capability. So in the capability architecture, you want to know these things. Right? So you want to know, for example, there is a capability team for certain technology. They want to know, for example, you are developing one application. You need to know in that partition that what is the context, right? Why we need it. So they are saying, okay, you develop this. See, most of the time developers have a less, but they have knowledge about the business. So you are developing one application. So you are saying, okay, I will send this file to the banking department, right? Their servers. So it means developer knows a file is coming from environment one and I need to ship it to the environment two. So that is basically your uh, context, logical, conceptual. What means what is the concept? What will be the services you need to develop, right? And how logic you will write it, and then how you will implement it. So in that case, all these abstraction models or abstraction levels are related to that capability architecture. Right. So this is all about the abstraction level. Uh, let us see in our notes. In TOGAF, abstraction level helps architects think logically and systematically about architecture they are designing, from purpose and requirements to implementation. So these are the one which I was talking about. Contextual, why architecture exists, what is the business context and motivation. Conceptual, what does the architecture need to achieve, what capabilities and the services are needed. Logical, how? How should the system be structured logically? What components and relation is required? Physical, with what? With what physical systems, hardware, platform, software is implemented. Right. So here in the why, business drivers, strategic goals, stakeholders, those comes into the picture. Conceptual, required capability, business functions, high level. In the logical component, data flow, interfaces, architecture models, and physical server applications, database, platform, network infrastructure. So now let us relate to our FoodieGo application. Let's talk about these levels for a new order tracking features in the FoodieGo application. Now, first question you will ask that why we need it. So business goal is that we need to improve the customer satisfaction with real-time order tracking. Okay, so we are adding in new feature, which is the order tracking in our application. So why we need it? Because there is a business goal that customer satisfaction is required. What are the drivers? Customer feedback showed the frustration in the uncertainty. So now the uh, now the drivers are, you know, the drivers are customer feedback showed the frustration, right? Why we need it? Because there are some negative feedback from the customer which shows their frustrations with the delivery uncertainty. So that is why we need it. Who are the stakeholder? Customer, delivery partner supporting. Now, what we need to do? What capability and services are needed? Capability needed, service delivery status in real time, notify the customer to delivery about the delivery progress. Customer business services, order dispatching, delivery progress update. So this is what we need. How we will do this? So how we design the architecture logically. Component, GPS tracking services, notification services, customer order portal. So we will develop these components. And data flow, the real-time location updates in the courier app to the central system and push the net notification to the customer application. How you will implement it? We will have the logical application, physical level, that mobile application, which is courier app is using for the GPS. Cloud service, AWS or IoT for the real-time tracking. Database, MongoDB for tracking delivery status. Front end, some application like Flutter app for Android and iOS customer. Right? So this is how abstraction levels comes into the picture. And these are very important whenever we are talking about this. Uh, Whenever we are talking about the architecture design. If you guys have any question, you can ask. Now, next is the building blocks. Okay, so let us talk about the building blocks. See, ultimately, what will happen that you need to deliver in the form of some packages. We call it work packages. And let us talk about the building blocks. Building blocks. So you can consider as a work package. Work package does not mean that it will be a executable files. It can be anything which is serving a model, which is serving a solution. For example, operation support model, that could be a building block. Okay, so we can say what is building block. So we'll say the building block is a package. So it is a package. What kind of package? It is a package of functionalities. It is a package of functionalities. And in what kind of functionality? Which meets the business needs. business needs across the organization. So building block is a package or it's a component of the functionality defined to meet the business needs across an organization. So it should be a recognizable things. Okay? So uh, we call it also as a thing. So it's a recognizable things. So what other definition you can say about this this package? So it is normally a type of uh, component, right, which corresponds to a enterprise model, meta model. So it corresponds to a package which corresponds to the enterprise meta model. Meta model means actor, business services, application, data entities, etc. Third one is that it has various level of details depending upon the objective of the enterprise architecture and the development stage. Okay. So it provides the details. Okay. It provides the details for enterprise architecture or enterprise architecture development stage. Right. Next one is that whenever we are using these building blocks, right? So it could be a tool, it could be an application, it could be, as I mentioned, some system, a thing which is in the enterprise architecture. So whenever you are having the building block, it can lead to improvements in legacy system. In legacy system, right? It can lead to the uh, improvement in the interoperability. What is interoperability? Means, for example, you are having one component and you want to import it into the another component. So whether now that can be interoperable or not, right? So if you are having the building block, so you are having that concept that interoperability and legacy system integrations and creation of the new system and applications. So creation of new system and application. In nutshell, building block is a thing in your, or it's a working thing, means work package, which is basically not logical, but you can say it is practical. It could be it could be an application. It could be a some solution, some process which is in place. It can be something which is related to your enterprise meta model. Okay. So now the organization must decide what arrangement of building block work best. Okay. So that basically your organization has to decide that. So for example, if they think that we are having this technology to to be placed like AWS or Azure or Google Cloud or on premises. Hmm. So those are the building blocks things you you need to consider. Do you have any question related to building block?
So
You
when you when
understood?
you when you say when you say the building blocks means the different components, right?
Hmm.
Another way.
Yes. So these are the components or the thing in your which is considered as a solution. Okay. So it could be a package, it could be a process, it could be a support model, right? So it can be anything which is, it could be a technology, right? So it could be your data, right? So if I say, now let me ask a question so that it will be clear to you what is building block. Now tell me, uh, I'm using uh, I'm using a I'm using a Jenkins tool. Consider Jenkins is a tool to develop CI/CD pipeline, which is a continuous integration, continuous deployment in my DevOps process. So Jenkins is a building block or not of my enterprise architecture.
Uh, Jenkins.
Jenkins is a tool.
Yeah, no,
Okay,
I got it. Okay. No, for my understanding, Jenkins alone won't be a building block because
No, it will
that
be.
will
It will be. See, it
will
will
be
be.
okay.
So
Right.
what I'm saying, it is a package. It can be a single package of the functionality meets the business need across the organization. It could be anything, means whatever is you are using as a functional thing, right? Which
Okay.
which
Right.
will be the, it can be a small minor things. It could be major, it could be intermediate level. It can be anything.
All right. Got it. I thought we call it like technology as a building block. Then then maybe Jenkins would be a part of it.
Yes, technology is there, but within technology, if we drill down, then Jenkins, because we are using the DevOps process. So
Yeah.
then Jenkins is the work package. Now, tell me one more thing that you are having, you want to apply a solution in your service. Uh, you need to apply a solution for the ticketing system. Okay. And that ticketing system is you are going to use ServiceNow, and you want that whenever there is a change happens into your whenever there is a change happens not change happens whenever there is an issue occurred into a server. Okay, whenever there is an issue occurs on the server, Dynatrace send the alert and ask a as ServiceNow to create the incident ticket. Now tell me, in that case, tell me in that case, ServiceNow, Dynatrace, servers are the building blocks or not?
Yeah, they are the building blocks.
They are the building blocks, right? Now consider you are using Dynatrace not only to monitor your on-premises servers, but you are also using Dynatrace for some other purposes, where it is used as a means you are using, or you can say you are using as a concept of reusability. So Dynatrace is work package or not, still work package or not.
Yes, it is still a work package.
Very good. It's still a work package, but we can reuse it. So that is the another advantage. So I hope now you guys can understand this building block. Let us understand that what is a good building block, right? So we need to meet certain criterias, right? On the basis of that, we will decide this is a good building block. This is the package which we are looking for. Whether we need to go with custom solution or whether we need to go with the standard tools, which is the best way, right? For example, you are having very small project, right? So you are having a small project, and in that small project, you are saying Dynatrace will be very costly for us because these are not free of cost. These are paid. These are the paid tools. So you're saying, no, it will be very expensive. We don't have that much budget. So in that case, you will be using the custom solution, right? So in that case, your building block is not Dynatrace, your custom solution. So now, if I say building blocks characteristics, or if I say how to have a good, how to decide a good building block. So first thing you need to, whenever you are deciding for a building block, first thing you need to consider the implementation, you need to consider the usage, right? Because maybe that tool is very effective as compared to the your custom solution, but it is not required, right? So if you find something, for example, you are developing a custom solution, but there is another tool which is meant for, which is not having that much functionality as Dynatrace is required, because your project does not need that kind of functionality. You just need to monitor the system, and you want to, you know, receive certain notifications, right? So in that case, the means custom solution or this standard one. So you will go with this standard one, right? So you need to consider the implementation and usage when you are deciding about the good building block. And you need to exploit the technologies and standards, right? So if there is a standard, maybe if the Dynatrace says that I have, different flavor of this, you can use that one, right? So that is basically your first characteristic. You need to think about the implementation. You need to think about its usage. You need to think about the technology. You need to think about the whether we need to go with the some standard if possible. Otherwise, if you think that we need to create a custom solution, you can go with the custom solution. Second one. Is it possible that, like I was giving you the example of the Dynatrace I'm using for, say an example, Windows-based system, whether I can use it for the Linux-based system also. So reusability, whether we can reuse, uh, we can reuse our building blocks. If so, then that will be considered as a good building block. Okay. Reusability. Consider today you are using uh, some another monitoring tool, and you want to, or you are getting some challenges, and you want it is to be replaced with some other tool. So whether the package which you are using, whether it is replaceable, reusable, it is having a well specified configuration. If you are having all this, then it is considered as a good building block package. Reusability, it should be replaceable whenever we want to replace it, and it should be well specified. Third, consider you are using a package which is monitoring package, say Dynatrace. Can we integrate with ServiceNow? Can we integrate with very popular, incident management systems? Can we integrate with you know, different technologies? Can we, um, we are having very old system, legacy system, Windows 2000 or maybe 2000, 2019 servers, Linux 5.7 version, and this will be work on that. Okay, so interoperability is the another factor which will make this building block as a good building block. Okay. What is the interface? How to use this? How to use this package? It should be simple. It should be stable. So that you can consider as a good building block. Third is, fourth is that it should be loosely coupled. What is loosely coupled means? Loosely coupled means their services, their implementation should be configurable. For example, if I say I need monitoring, I don't need the integration with ServiceNow. So tick mark, and or maybe deselect, or by default it is not having the option to connect with the ServiceNow. So that is loosely coupled. If you are having such kind of functionality into your work package, then it is considered as a good building block. Fifth, you can that we have discussed that integrate with this. Yeah. So these are some points, right? So whenever you are deciding about the building blocks, so we are basically considering those things. Right? So it is not like that there is a package and that package we can integrate it into our enterprise architecture. So it should be good building block. All right. So let us see our notes. So building blocks. A building block is a reusable component that can be combined to other uh, building blocks, uh, combined to the other building architectures or the solution. Think like a Lego bricks, right? You can combine them in different way to build different structures, like normal bricks when you are making a building, offices, this and that. So building block is a package of functionality defined to meet certain business needs, recognizable to domain experts. So these are, uh, you can say, that's order tracking module. mapped to the elements of the enterprise meta model, like business services, actor, data entities, and can be reused and replaced, assembled, and evolved, exist at multiple level of detail depending upon the architecture phase. Okay, so we will talk about this architecture building block, ABB, and solution building block, which is SBB. So let us understand building block characteristics. That is what I have mentioned, considering implementation and usage, designed with the current technology and future evolution in the mind, and reusable and replaceable, composable and interoperable. Means it can be assembled from the other blocks or integrated via stable interfaces, loosely coupled. So now, so these are the building blocks. Now, let us talk about uh, the two types of building blocks. Okay, so there are two types of building blocks. So we are having uh, this. We are having the building blocks. So first, it is called architecture building block. And second is called solution building block. So it means the packages, work packages which are required for architecture point of view. In short, we call it ABB, application building block. And this we call solution building block, SBB. Right? So architecture building block. So these are the architectural component which describe the required capability, logical or supplier independent kind of things. So those are coming in the architecture. Right? What are the components which describes the capability, right? Logical or the supplier independent. Solution building blocks. So these are basically the implementations. Okay. So you can say in the architecture, we are defining the design. Okay. So in the design, whatever the components you are saying, for example, you are saying my department one can communicate to department two. How business goals are to be mapped to the technology, to the data, uh, to the applications. So you are basically giving a shape of specifications in the architecture building block. In the solution building block, right, you are implementing implement the capability. Okay. Let us see with the example. So if you see here, architect logical definition of capability or function not tied to the implementation. Actual product is the solution or system component that realizes ABB technology specific. Now let us see the example. order management is, it's not the implementation, it's a definition. We will create the order, this. We are still talking design point of view. So this is architecture. GPS tracking service, logical capability to track the real time of deliveries. Mobile notification app. So actual mobile app module sending the real time push notifications. So this is the solution. So where we are talking about logically means we are not talking about the implement point of view. Those are architecture. And the one where we are saying, for example, MongoDB order. So MongoDB is a technology. So that is a solution building block. Payment gateway service. So there will be a service which will send the means capability to process the payments and refunds. So this is design. So this is the architecture building block. Right. For example, you are having a order management. It is a architecture building block realized by solution building block. It will create the REST API service and implement it. Right. Alternatively, you are having a serverless AWS and Lambda operations. So these are the two types of building blocks. Any questions, guys? Hmm? So we will stop our discussion here. So what we have discussed in this lecture so far, that what are the abstraction levels, which we have discussed: contextual, conceptual, logical, physical levels. Then we have discussed about those what are the advantages, what are the use cases of that. After that, we have discussed about the building blocks. We have also earlier discussed about the partitioning benefits, right? And then we discussed about the building blocks usage, building block, what it is basically. These are the packages, and two types of building blocks: ABB, architecture building block, SBB, which is the solution building block. All right, so let's wind up today's session here. You guys wants to connect tomorrow also, or you want a break for tomorrow?
I think let's skip for tomorrow.
Take a
Okay.
break, connect on Monday.
Okay, so let's take a break on tomorrow, and we will meet on Monday then. Hmm? If you have any question, you can ask me. Okay. See you then. Thank you. Bye bye.
All right.
Thank you.
See ya.
Bye.
Thank you. Bye.